Good day everyone. For today's video discussion, we'll continue the part 4 of the conic section, which is hyperbola. And I hope at the end of the lesson, you should be able to do the following. First, name the parts and properties of a hyperbola. Second, write the equation of a hyperbola. And third, sketch the graph of a hyperbola. If in the previous video discussion, we deal more on the standard form of a hyperbola given center at the origin, now this time we will focus on the standard form of the equation of a hyperbola given center not at the origin, or in other words, the center is at any point on the Cartesian plane. Still, the equation of the hyperbola depends on the orientation of the principal axis. If the orientation of the principal axis is horizontal, then the equation of the hyperbola is given as the quantity of x minus h squared over a squared minus the quantity y minus k squared over b squared is equal to 1. And if the orientation of the principal axis is vertical, then the given equation is quantity y minus k squared over a squared minus the quantity x minus h squared over b squared is equal to 1. So for our first problem, we are asked to determine the standard form of the equation of a hyperbola given center located at 2, 2. The transverse axis is horizontal, a is equal to 3, and b is equal to 4. Then we are asked to sketch the graph of the given hyperbola. First thing first, you need to determine the standard form of the given equation. Since the transverse axis is horizontal, it means that it lies on the x-axis. So we are guided with an equation quantity x minus h squared over a squared minus the quantity y minus k squared over b squared is equal to 1. Then substitute the values of a and b. Then our desired standard form is quantity x minus 2 squared over 9 minus quantity y minus 2 squared over 16 is equal to 1, given that the values of your h and k, h is 2 and k is also equal to 2. And for us to determine the coordinates of the vertices, foci, and co-vertices, then we need to determine the distances a, b, and c. Since a is given as 3, b is given as 4, then we will determine the value of c using this relationship c squared is equal to a squared plus b squared. So substitute the values of a and b. You simplify the equation. So we have here c squared is equal to 25. Take the square root on both sides of the equation. So c is equal to 5. So we will be using the values of a, b, and c to sketch the graph, and of course to determine the coordinates of the vertices, foci, and the co-vertices. Now, in graphing a hyperbola, you locate first the coordinate of the center. Now, in this problem, the center is located at 2, 2. So it's here. Then we will use the values of a, b, and c to locate the, the points of the vertices, foci, and the co-vertices. So since the transverse axis is horizontal, then I will count 3 units to the right and to the left side of the center for me to determine or to locate the vertices. So that's 1, 2, 3. This is vertex 1. Then another 3 units to the left of the center. It's 1, 2, 3. And this is our vertex 2. Then I will be using the value of our c to locate the coordinate of the foci. Since c is equal to 5, I will count 5 units to the right and left of the center. So this is, allow me to erase first the v of 1. Okay. So Focus 1 is located 1, 2, 3, 4, 5. Focus 1 is located here. And focus 2 is located 1, 2, 3, 4, 5. This is our focus 2. Okay. Now, since the transverse axis is horizontal, it follows that the conjugate axis is vertical. So I will count 4 units above and below the center to locate the co-vertices. Now, so 4 units above the center, that's 1, 2, 3, 4. This is co-vertex 1. And another 4 units below the center, that's 1, 2, 3, 4. This is co-vertex 2. Then construct an auxiliary rectangle joining the vertices and the co-vertices. Okay, that's our auxiliary rectangle. Then after that, construct a line that passes through the corner of the auxiliary rectangle. So this is our first asymptote and our second asymptote. Then we can now sketch the graph of the hyperbola. Okay, asymptotic to that line. Okay, asymptotic to that line. So this is now the graph of the given hyperbola, and based on the location of the points, our v sub 1 is located at 5, 2. The v sub 2 or the vertex 2 is located at negative 1, 2. The foci is located, the focus 1 is located at 7, 2. Focus 2 is located at negative 3, 2. The co-vertex 1 is located at 2, 6. And the co-vertex 2 is located at 2, negative 2. So these are the parts of the given hyperbola. This is our desired equation, and of course, this is our graph. Okay? Okay, allow me to erase first the annotation for us to proceed to the second problem. Okay, for our second problem, we are asked to determine the standard form of the equation of a hyperbola with center at 1, negative 3. The transverse axis is vertical, b is equal to 4, and c is equal to 6. Then after that, we are asked to sketch the graph. Again, first step, we need to determine the standard form of the given equation of the hyperbola. Since the transverse axis is vertical, it means that it lies on the y-axis. Thus, we are guided with this equation. Since the given problem, a is unknown, then we need to solve for the value of a given b equals to 4, c is equal to 6, and we will solve a using this relationship. C squared is equal to a squared plus b squared. So substitute the values of b and c. You simplify the equation. So we have here a squared is equal to 20. You take the square root both sides of the equation. The square root of 20 is 2 square root of 5, and that's approximately 4.5. So we now have the value of a and b. Then substitute that to our standard form in order for us to get our desired standard form of the equation of the hyperbola. Thus, our desired standard form is a, b, h, and k. And then our equation is quantity y plus 3 squared over 20 minus quantity x minus 1 squared over 16 is equal to 1. Then, for us to determine the coordinates of the vertices, foci, and co-vertices, we will be using the values of the distances a, b, and c. Take note that the transverse axis is vertical, thus our movement for vertices and foci is vertical, and our movement for the co-vertices is horizontal. Okay, so we will start locating first the center. The center is located at 1, -3. Okay, allow me to change the color. Okay, 1, -3, that's the center. Then I will count 4.5 units above and below the center for me to locate the vertices. That's 1, 2, 3, 4. 4.5 is approximately here. So this is our vertex 1. Then another 4.5 units below the center. That's 1, 2, 3, 4. 4.5 is approximately here. And this is our vertex 2. Then I will count 6 units again above and below the center for me to locate the foci. 1, 2, 3, 4, 5, 6. This is our focus 1. Then 1, 2, 3. Again, 1, 2, 3, 4, 5, 6. This is our focus 2. Then use the value of B as 4 to locate the co-vertices. So I will count 4 units to the right and left of the center. That's 1, 2, 3, 4. This is co-vertex 1. And another 4 units to the left side of the center. It's 1, 2, 3, 4. This is our co-vertex 2. Then construct the auxiliary rectangle joining the vertices and the co-vertices. So this is our auxiliary rectangle. And after that, construct two lines that pass through the corner of the auxiliary rectangle. This serves as the asymptotes of the given graph. Okay, so we now have the auxiliary rectangle and the asymptotes. Then we are now ready to sketch the hyperbola. Okay. Okay. So this is the graph of the given hyperbola, and based on the location of the given points, our vertex 1 is located at 1 and -3 plus 2 square root of 5. Our vertex 2 is located at 1 and -3 minus 2 square root of 5. The focus 1 is located at 1, 3. Focus 2 is located at 1, -9. The co-vertex 1 is located at 5, -3. And the co-vertex 2 is located at -3, 3. So these are the basic parts of the given hyperbola. This is our desired standard form, and this is the sketch of the graph of the given hyperbola. So again, if you have questions in mind, if you have clarifications, feel free to message your pre-calculus teacher. I hope that you learned something today, and see you in our next video. Have a nice day, everyone.